For the lab 5 of SRT521, first task was to split the dataset, and for that I have used the Python program, Python script lab5a.py. So I'm going to take my program here, lab5a.py. As you can see, first I have imported the pandas library and then have read the dataset.csv, which was created for lab 4, 3 and 2, and I have read the header. Then I have read the data from the CSV file into a data frame object. So here, as you can see, I have created two lists, mal and ben. So here what the program does is it obtains 30 random samples from Benningware and from malware from the dataset.csv. So here first it checks. So I have used a for loop, and here it checks for row in data, like if row 1 equal to malware. So if any row contains malware, then it will be appended to the malware list. So for that I have used mal.append row. So it checks every row, and if any row contains malware, so it will copy the entire row to mal list, and if it doesn't contain malware, so it will be printed to ben list. So if it's not a malware, so for our lab we have two options, whether it's a malware or benware. So if it's not a malware, it will be printed to ben list. So it goes to else loop, else statement. So next I have read both of them, added them both of them to a data frame. After that, using concat, the selected samples, 30 samples from malware and benware, are being joined. So after they are joined, I have selected the first two columns like empty5 hash and label. So these are going to be returned to samples.csv. So for that I will return j.to.csv samples.csv file. So next I'm going to remove this selected data using a for loop. I am going to remove the data, the selected data from the original dataset.csv. So for that I am using a for loop again. So if I'm checking like if row matches in benware and malware, then the data will be removed from the original dataset.csv. So after that, this after removing the file 60 samples from the dataset.csv, this is being written to another file called reduce dataset.csv. For that I'm using reduce df dot to underscore cf csv reduce dataset.csv. Okay, so I'm going to run the program. As you can see, two files have been created. So I'm going to open the file. Okay, it's in my downloads. So I have to check for the file. Okay, so these are the two files, samples and csv. So here I'm going to open reduce dataset. So this is my reduced dataset, and the number of files is reduced here. So it's 1153 because my dataset.csv contains more than this number of files. And I'm going to open my samples.csv. So here two columns have been copied, empty5 hash and label. So as you can see, malware, like the number of malware is 30. So from 2 it starts and till 31, and the number of benware it's also 30. So it starts from 32 and ends on 61. So the number of malware and benware are 30 each. So task 1 is completed. And for the next part, I have used the script. Okay, next task is for feature selection using cross validation, and for that I have used the script lab5b.py. Okay, so it's a big script. So first of all, the modules have been imported. NumPy, pandas, stratifield, k-fold, select k-best, select percentile. So all the necessary, and then cross validation and model selection. So all the necessary modules have been imported. Next, I'm reading reduce dataset.csv and adding it to a data frame. So for extracting the features only, I'm dropping the first three columns. So MD5 hash column, label column, and target column is being removed. So in y underscore base, I'm giving the target column. So in my dataset, I had the target column, so I'm giving reading from fourth column onwards, which my zeroth column is MD5 hash. First column is label, and second column is target. So I'm reading from third onwards. Okay. Then I'm splitting the data using stratifield k-fold into 10 folds. For that I use this command. I'm splitting my L2 and y underscore base. So here I have created two lists, X and Y. So what this program does is X is being used to store the names of the feature selection methods that I'm using, and Y stores the features selected by each feature selection method. For example, first I'm using select kbest chi2. So using this method, I'm getting 15 features. So the name of the method is being saved to X list, and the result, the 15 features that I get after running this script, this will be saved to Y list. So like this, I'm using select kbest chi2, select kbest chi2 with mutual information, select percentile method, then select percentile mutual info method. So after that, I'm using svc2. So these are so I'm printing my list X and Y. So after that, I've used decision tree classifier, and I'm printing a classification report for each method. So as you can see, I have given different variables here. So it is represented in different variables. So I can print different classification reports for each method that I have used. And after that, I'm calculating from the classification report. I made a list of the F1 scores. So before the okay, so before that, I have used the cross validation score function to calculate the cross validation score and the mean cross validation score. So there are 10 folds in my data, so it will print 10 cross validation scores. And so in the next line, using this command scores.mean, I am printing the mean, and after that I'm printing the mean of the F1 score and the standard deviation. So I'm going to run the program. Okay, the program is being run. I'm going to expand the screen. Okay, this is my second program. Okay, yeah, so the program is being run, and I could see I've printed X and Y. So this is my X and this is my Y list. So after that, I'm getting the classification reports for each method. So the first one, select kbest chi2, then select kbest chi2 with mutual information, then select percentile mutual information. And these are the cross validation scores that I'm getting for the 10 folds. So these are 10, 1 2 3, yeah, there are a total of 10 scores, and I'm calculating the mean score. So from the F1 score, I created a list, and I'm printing the mean F1 score for each method. Select kbest chi2 mutual information, select percentile mutual information, and standard deviation of the F1 score for each method. So from this, I'm getting for select k best is having the highest mean value. So this is being noted. Okay. For the next script, I made the Python script lab5c.py. Yeah. So here, okay, and here what I'm doing is first I have imported all the modules. I just copied from 5b to 5c, and so here I'm importing model selection methods like Bernoulli, NP, random forest classifier, decision tree classifier, SVC, etc. So first the reduced dataset.csv file is being read. Okay, and so the steps from lab task 2 is being repeated, like dropping the labels, simplify hash label and target, then creating 10 folds of and creating two lists. Till that step it is being same as that of task 2. Then I have used the select k bus chi2, and the reason why is that from task 2 the highest mean value was for select k best method, so that's why I have used select k best here. And next I have used decision tree classifier model selection method, and I'm creating a classification report for that, and I'm calculating the mean score, cross validation score also for that method. Like this, I'm printing for random forest classifier. I use random forest classifier, Bernoulli NP. Okay, and SVC. And for each method, I have printed the classification report and the mean cross validation score. So with that, I have created from the classification report again. I've created a mean like a list of the F1 scores, and I'm printing the mean and standard deviation of the F1 score. So now I'm going to run the program. Hopefully it runs. Yeah. So here you could see the classification report which was created for each method. First one for the decision tree model and the mean cross validation score. Then random forest, Bernoulli NP, and SVC. So for that, for Bernoulli NP, I'm having the least F1 score compared to others, and here I have my cross validation score for that, and mean F1 score for each models, and the mean standard deviation for all of the methods that I have used. So the program is running successfully. And next one is task 4. For that, I've created 4 different scripts. One was already given. Okay, what was the name? Okay, detector.py script. And for that, I've done every step in a Ubuntu machine. So I'm going to open my Ubuntu machine, and so here I have my script lab5d1, lab5d3.py, 5d2.py, then detector.py. So first I ran the script. What the program does is first it opens the samples.csv file and checks the MD5 hashes, and it opens the malware. So here I'm given Benigware directory first. So it goes inside the Benigware directory and calculate the hash of each files there. And if the hashes matches, then it copies it to sample directory. So I already ran this file. So here I already ran this file. As a result, in my samples.csv, I got a folder samples.csv, and as a result, I'm having around 60 files, like 30 malware and 30 Benigware files being copied. So I did it for both the directories. So here I did the same step for both directories when I ran the program. Okay, next program is left5d2.py. So here for d1.py, I'm specified the path to samples. So if the hashes matches, then it copies the file to the samples directory, and same I did for pen malware too. So here I'm given penanywhere. So this is the same step that I did for malware directory too, because I had both 30 malware and 30 penanywhere samples, and both are in different folders. So that's why I need to run the program twice. And for the next script, okay, left5 d2.py. Okay, first I'm importing the necessary modules, and then I'm loading the dataset reduced dataset.csv into the data frame. So I have added another label target. This was already, like, I was already having this label, so I didn't want to add the target column. I already had this in my reduced dataset.csv, and I'm first dropping the three columns, like the MD5 hash, label, and the target column. So this is done for extracting the features only. So next I have did the feature selection using the select kbus chi2 method, and I have given k equal to 15, so it prints 15 features. I get 15 features. Okay, this is what, like, these three lines does this. And next I used SVC model, train the classifier using SVC, then save the output to detector saved detector.pkl, and for this I'm going to run the program. So I already have the file that I got when I ran the program, so I'm deleting the file. So now I'm going to run id2.py. So as a result, we could see that I'm getting the save detector.pkl file. So the task 2 is done. And for third part, I used detector.py script. Okay. So I already have the detector.py log. So I'm deleting that. Now what I'm doing is I'm opening the detector.py program. So this was already provided. So here I'm giving the path to my samples directory, which have that 60 malware and benefit files. So next I have commented the second process and commented out the first process. Okay, I'm going to use kappa here. So what I did is I copied kappa, which was in my directory, so to here. So then the program doesn't take the kappa from the folder, so that's why I'm pasting it in the same folder and where I have my detector.py script. So now I'm going to run the script. Okay, for the detector.py, and hopefully it's going to take some time for running. So as the program runs, my files get deleted from my samples directory, and a script is being made. Okay. Detector log. As the program runs, it creates a timestamp, then the MD5 hash, then label like the benefit or malware, then the probability. So this is being done. Now I have around 57 files left. So I will explain the next one, lab 5D2.py. So this is going to take some time, so I'm going to cancel this script running. I have my script in my trash, so I'm going to delete the detector.log. I'm going to copy the detector log from the trash. Okay, I think this is the one. Here I should be having all the files. Contains, yeah, all the files. So here now I'm going to run lab5d.py. So what this program does is, first it, like the modules are being imported, then first it reads samples.csv file. So another label called target is being added to samples.csv file. Then the detector log file is being opened. So what it does is it converts the JSON objects into simple strings for classification for the processing. So I have used JSON.loads function for doing the conversion, and I have created three lists: condense, wipe predict, wipe probe, and so I'm reading the classification form from the log generated by live classification, and if it's a malware, it is appended 1. As you can see, it is appended 1, and so it goes to wipe predict. If it's not a malware, then it is appended 0 and goes inside y probability, y prob list. So after that, I'm printing the classification report and the confusion matrix, and at last I'm creating the plot and displaying it, and I have used plot.show command for displaying the plot. ROC curve is also being created, so now I'm going to run the program. Okay, I copied detector log here in document 60 files. This is the actual one that I got. Now I'm going to run the program. cd documents / lab 5d3.py. So here when I run the program, I'm getting a classification report, and then I'm getting a confusion matrix 300822. Then I'm getting the graph here, like the plot here, and the AUC is 0.87. Then the receiver operating characteristic curve ROC curve is being created here, and both are perpendicular to each other. True positive rate and false positive rate is perpendicular to each other. And that's all. Thank you.